NASA is about to launch a telescope that can see 100 times more sky than Hubble in a single image. And it could help us understand dark energy, discover thousands of planets, and reveal things in the universe we don't even know exist yet. This is the Nancy Grace Roman Space Telescope. Let's dive in. Let's start with the launch. NASA is currently targeting August 30th, 2026. Roman will launch aboard a SpaceX Falcon Heavy from Kennedy Space Center in Florida. And after launch, it won't stay anywhere near Earth. It will travel roughly 1.5 million kilometers to the Sun-Earth Lagrange point 2 or L2. So what exactly is L2? Imagine the Sun here, Earth here, and Roman another 1.5 million kilometers farther away from the Sun. Roman won't simply sit at one fixed point. It will orbit around the L2 region. And if that sounds familiar, it should, because James Webb operates around L2 as well. From there, the Sun and Earth remain in roughly the same direction. That gives Roman a stable environment for observing, power generation, communications, and thermal control. And just to put the distance into perspective, Roman will operate roughly 4 times farther away than the Moon. So once it's out there, there's no astronaut repair mission coming to the next rescue. Now here is what makes Roman so special. Roman's primary mirror is 2.4 meters across. That's essentially the same size as Hubble's mirror. And Roman will produce images with roughly Hubble-like sharpness. But here's the game changer. Roman's wide field instruments can see an area of the sky at least 100 times larger than Hubble. One Roman image can therefore contain roughly the same area as 100 Hubble images. And NASA says Roman could survey the sky up to 1,000 times faster than Hubble, while maintaining similar sensitivity and infrared resolution. Think about it this way. Hubble gives us an incredible zoomed-in view. Roman gives us the panorama. In its first 5 years of observations alone, Roman is expected to image more than 50 times as much sky as Hubble covered in its first 30 years. That's the real superpower of Roman. Roman isn't replacing Hubble, and it isn't replacing Webb. They complement each other. Webb has a much larger 6.5 meter mirror and is designed to look extremely deep into the infrared universe. Roman's mirror is smaller, but its field of view is enormous. So imagine Roman surveys a gigantic area of the universe and discovers something unusual. A strange galaxy, a supernova, an exoplanet, or something completely unexpected. Then Webb can take a much closer look. I like to think of it this way. Roman finds the forest, Webb studies the individual trees. And this huge field of view is especially important because Roman is going after two of the biggest mysteries in physics: dark matter and dark energy. We know that the expansion of the universe is accelerating, but we still don't really understand why. We call whatever is driving the acceleration dark energy. Roman will study enormous numbers of galaxies and exploding stars across cosmic history to investigate how the universe expanded and how that expansion changed after billions of years. Over its mission, Roman could measure light from around 1 billion galaxies. Then there's dark matter. We can't see dark matter directly, but we can see what its gravity does. Roman will use effects such as gravitational lensing, where mass bends the light coming from objects behind it. By studying those distortions across enormous regions of the sky, scientists can essentially map where invisible matter is located. So Roman won't just photograph the universe, it will help us map the invisible universe. But Roman isn't only about cosmology, it's also a planet hunter. Roman will monitor hundreds of millions of stars toward the center of our Milky Way. Using a technique called gravitational microlensing, NASA expected to discover more than 1,000 exoplanets. And Roman carries another fascinating instrument, a coronagraph. It blocks the overwhelming light of a star so we can see much fainter objects next to it, like planets. The coronagraph is primarily a technology demonstration, but the technology Roman tests could help pave the way toward future telescopes capable of directly imaging worlds more like our own. Roman will also study black holes, supernovae, galaxy evolution, and star formation. But there's another possibility I find even more exciting. Roman will repeatedly photograph huge regions of the sky. So astronomers can see things changing, objects appearing, disappearing, exploding, moving. NASA describes this almost like creating cosmic time-lapse photography. And that means Roman isn't only designed to answer questions we already have. It could discover things we don't even know we should be looking for. And historically, those are often the most exciting discoveries in astronomy. Will we get spectacular pictures like we get from Hubble and Webb? Absolutely. But Roman's strength will be different. Instead of one incredible detailed little piece of the universe, imagine gigantic cosmic panoramas containing millions of objects. Roman's wide field instrument is basically a gigantic 288 megapixel infrared camera. And the amount of information will be enormous. NASA expects Roman to generate around 11 terabits of data per day and roughly 20 petabytes during its 5-year primary mission. Which brings us to something very 2026, AI. Roman itself isn't an AI telescope, but AI and machine learning could become extremely important for analyzing its data. Because there will simply be too much information for astronomers to manually inspect everything. NASA-supported researchers are already developing machine learning techniques to search Roman's future observations for planets, cosmological patterns and unusual objects. So AI isn't flying Roman, but AI may help us discover some of the most interesting things inside Roman's data. Roman's estimated life cycle cost is around $4.3 billion. The mission's development stretches back well over a decade. It was originally called W-FIRST. In 2020, NASA renamed it after Nancy Grace Roman, NASA's first chief of astronomy, often called the mother of Hubble. And now, after years of development, construction and testing, Roman is finally almost ready to fly. But August 30th is only the beginning. Falcon Heavy first has to put Roman onto the correct trajectory. Roman then has to establish communications and power, travel toward L2, activate and check its systems, calibrate its instruments and complete commissioning. Only after all of that can serious science begin. So don't expect spectacular Roman science images the morning after the launch. The first engineering and commissioning images should come earlier and the big science observations later. NASA's primary mission is planned for 5 years, with the potential for another 5-year extend mission. And considering how much sky Roman can cover during that time, those 5 years could completely transform several areas of astronomy. Hubble gave us some of the most iconic images of the universe ever created. James Webb is taking us deeper into the infrared universe than ever before. And now Roman will give us something different. The wide-angle view. Billions of galaxies, thousands of planets, dark matter, dark energy, black holes, and perhaps something nobody has predicted. On August 30th, Falcon Heavy is scheduled to launch this $4.3 billion observatory toward L2. And when Roman finally opens its eyes, we may see the universe in a completely new way. I'm Alex, this is Alex SpaceX Talks, and I will see you when Roman meets the universe.